Recording in progress. All righty. And now I should be able to get this thing going. All right, there we go. Sorry for the delay. Still want to get the chat going here. All right, so again, welcome everyone, finally, for this workshop. We're really excited. I say workshop in quotes because it kind of turned into a monster with 250 registrants. That it's now not really a workshop feel anymore. It's more like a webinar. We don't see you. It's very unfortunate. You don't see each other. But we will make the most of it. So this workshop, this webinar is about Bayesian analysis for speech scientists. Most of you are speech scientists. We are really excited. We obviously don't see your faces, but we know there are a lot of familiar faces in the crowd. That's fantastic. And it illustrates really that, learning opportunities for this topic are still scarce and really much needed in our field, across other fields as well. But it's also somewhat challenging for us to handle, and we have never handled such a big crowd digitally before. So please bear with us if there are technical hiccups. That's why we decided to switch off all your cams and mics to keep it kind of wieldable for us. And I hope that you're not too disappointed by that, but you will see plenty of us. Who are we? Well, and who the hell do we think we are standing here telling you about statistics? Maybe I can ask my two co-hosts to switch on their cam real quick and introduce themselves to our crowd. You want to go ahead, Stefano?
Yep. Hi, everybody. I'm Stefano. I'm currently a postdoc researcher at the LMU University in Munich, Germany. And yes, I basically work with articulatory data and acoustic data. And I'm a big supporter of Bayesian statistics.
Thank you, Stefano. Joseph?
Hello, everybody. My name is Joseph Casillas. I'm an assistant professor at Rutgers University in New Brunswick. And I'm also a big fan of Bayesian statistics. I work on phonetics and phonology of bilingualism, specifically second language acquisition, spoken word recognition, speech production, perception. And really excited for the next couple of days.
Thanks, Joe. My name is Timo Röttger. I'm an associate professor at the University of Oslo in linguistics. You might know me as kind of a troublemaker, kind of pointing to the things that might go not too well and pointing out how we can kind of improve them. And I'm not an expert in Bayesian, I would never say, but I happen to be one of the first ones that try to use it in our field. So I see me as just one person that has a little bit more experience with it than you have. Now, I want to stress something, since you see those guys here. These two, for me, it's up and down, wonderful human beings here really did the heavy lifting, okay, for this workshop, including its technical implementation. You might not know, but you will soon appreciate the R package that Stefano in particular developed for this class. And my main contribution here was really standing behind those guys with a whip, enforcing my OCD schedule on them. So I do take all the blame if something goes horribly wrong. But if you have any praise to share, you should definitely share it. It should go to Joseph and Stefano. All right, okay. As you know, I think you guys can, for now, switch off the cams. As you guys know, this workshop is supported by the Association for Laboratory Phonology. The event and outreach committee led by Molly Babel reached out to us and made this happen. So big thanks to them. And it's really great to see how much effort LabPhone invests to create learning opportunities such as this one here. And although we would all love to see each other in person, I mean, it's great that this digital event, offers an opportunity for people all over this planet to join and learn together. We We hope this workshop also attracts some new members for the Laboratory Phonology Association. If you're interested in speech from any kind of angle, LabPhone is really the community to be part of. And before we jump into juicy content, I know you can't wait for it. Let us do a little bit of housekeeping for this workshop. As already mentioned, you won't be able to directly interact with us using video or audio. I know it's a bummer, but that makes things for us a little easier. There are 3 channels of communication, okay? You can post in the Zoom chat, you can post in the Slack chat, and you can post in our dedicated Q&A Google Slide tool. If you have questions that you would like us to answer during the webinar, please use the Google Q&A tool with slides. And Stefano hopefully posts the link in the Slack channel, as well as in the Zoom chat in a bit. So basically go to a web page that has like a dummy slide. There it is. The link is up in the Zoom channel. So I recommend you opening that tab in your browser and leave it there. Right. This allows you to post questions, and if you want to, you can post them anonymously, which is great, right? If we feel a little insecure about asking silly questions, they're not silly questions, but if we are kind of anxious about that, posting them anonymously is nice. You can also upvote and downvote questions for others, and that's really cool because that way we can see what is particularly urgent to answer at that point in time. Okay. After each individual content sessions, we will try to answer a few of these upvoted questions, and we will make notes of those that we can't answer and see whether we can prepare something for next time. The 2 conveners that are not currently presenting, so right now that's Joseph and Stefano, they will try to monitor these questions. And if something super urgent pops up, they might even interrupt the speaker at that time if there's clarification needed. You can use Zoom, but we will not monitor the Zoom chat live. So feel free to communicate with each other and help each other out using the Zoom chat, but we won't look at it. You can also use the Slack channel, but again, we will not monitor the Slack channel live. We will look at it later and try to answer your questions either in Slack or possibly preparing something for tomorrow review. Okay. Now, there's also a material website that is part of the R package that Stefano has whipped up. So maybe, Stefano, you can post that link into the chat as well. Again, I mean, we've already shared this several times. On this web page, you find our slides, you find possible R Markdown exercises. We will point to that later on, and other helpful informations, including an FAQ for this workshop. Okay, so there it is in chat. It's on our learnB4SS github.io page. And it's an incredible resource. So please have a look. The slides should be all up except for one, I think, my review session tomorrow. And the markdowns are also up as well. And this will be continuously updated. All right. So that was kind of housekeeping. Let's dive into it a little bit. Yeah. Let's kind of try to answer the question why we are here. Why are we here teaching you these things? And why are you here sitting here for 4 hours today and tomorrow to learn something about Bayesian statistics? And there are many answers to that, and here's my angle, and my angle is kind of always the same. So for those of you who know me, I might sound like a broken record. So a bunch of psychologists selected 100 studies from the most prestigious psychological journals. That's a while ago, in 2015. And they try to replicate these studies, try to reproduce them. They use the exact same methods and analyses of the original studies, just with new, larger sample sizes. And what you see in the slide here, that's the picture we would like to see. Maybe the picture we believe in, right? Certainly a picture that the public, the non-informed, the non-initiated believe in when they think about science. We would like our research to be robust, to be repeatable, our results to be generalizable. We want to learn something about language that is real, right? That's generalizable. But in reality, they were able to replicate less than half of the original findings, right? Now, you might say this is one study, we should be careful. It might be just a bunch of bitter scientists with a hidden agenda. How representative is this project? Well, it turns out we find similarly alarming replication rates in many other disciplines. For example, economics and medical sciences and the social sciences. And there are reasons to believe that we might struggle with similar issues. So quantitative science, they struggle to replicate published established findings. That's a fact. And whether this is a crisis or not is really debatable. But it surely did something to sciences, and it created a constructive and productive dialogue, actually. And one part of this dialogue is a re-evaluation of the tools that we scientists use. One part of our job lies in identifying discoveries, while at the same time avoiding to overinterpret noise. If we overinterpret noise as, for example, evidence for a phonological category, yeah, we might make with confidence a false discovery, which is then published, others read it, and it might not be replicated in future studies. Imagine our bread and butter day-to-day, right? We run a speech production experiment, let's say. Right? We measure, say, fundamental frequency across different social conditions. Say we measure fundamental frequency in Korean speakers that either were in a formal or an informal environment, depending on who they speak with. Right? Given our understanding from the literature, we have a clear hypothesis, that is that the use of fundamental frequency is meaningfully different across formal and informal environments. Okay? What tools do we use usually to test this hypothesis quantitatively? We pick one of these tools, we use the X. Okay? And the X is null hypothesis significance testing. Still the most widely used inferential framework across all quantitative sciences. And I don't think it's a stretch to say that is the framework that dominates speech sciences at the moment. Right?
Timo, sorry to interrupt. Perhaps we can do the quick poll now before we move on.
Let's do that after the Y session.
Sure.
In like 3 minutes. Okay. That's a perfect break for it.
Absolutely.
Thanks for the reminder. Now, let's first, before we do a poll and kind of brief, let's work through something very, very complicated. Okay, null hypothesis significance testing. We have all done it probably. We've been taught to do it to some extent. Now, let's just remind ourselves of the logic of null hypothesis significance testing. It's pretty weird. Part of the reason of its weirdness is that it is historically grown out of two different schools of thoughts that were later somehow combined with each other in a weird way. Let's remind ourselves, the logic of NHST goes like this. First, you set up a null hypothesis. Say, fundamental frequency does not differ across different contexts. That null hypothesis is represented as a distribution of values of a test statistic. Let's say a t-test, for example. This distribution is centered on 0, as you can see here, of course. And the assumption is that the true value is really 0, but there's some noise in the sampling procedure. Therefore, you get a normal distribution around 0. If you run the study over and over again, an infinite amount of time, the exact same study, then you would get a distribution like this one. Does your head hurt already? Right? Mine starts to kind of itch a little bit at the back. Second, what do you do then? Well, you measure the fundamental frequency values of your recordings, and you calculate a test statistic based on that measurement. Say you get a 2.3, something like that. Now you calculate how probable is 2.3 or more extreme values if the null distribution is an accurate reflection of reality. That is, you calculate the proportion of that blue area on the right-hand side of the blue line, the area under the curve that is light blue, okay? That probability, that is your p-value. It is the probability of the observed results or more extreme results if the null hypothesis was really true. And at this point, your head must hurt by now. Mine starts to really hurt, okay? Now, we're not done yet. The p-value is probably the most widely misunderstood, but also at the same time, most widely used index across all sciences. Now, we ended up with this number. What next? And here's the kicker for null hypothesis significance testing. There's another trick to that procedure. We don't only calculate this probability and call it a day. We actually use this number and make a black or white, a thumbs up, thumbs down decision regarding the research hypothesis. The final step, and that is an important component of this framework, is a decision procedure. You will hear that term several times during the workshop. We conventionally consider every value, p-value that is smaller than 0.05 as significant. If you find a significant result, we reject the null hypothesis. Remember here, the null hypothesis was pitch does not differ across conditions. Our p-value is below 0.05, so we reject that hypothesis because it is rather unlikely to observe what we have observed if pitch really does not differ as a function of formality. If you feel overwhelmed now, good. If you're not feel overwhelmed, you're a monster, okay? Because let me tell you why this framework is not the right tool for us and why it really confuses us. Null hypothesis significance testing is trying to hammer a nail into the wall with an axe. The way it's practically implemented at the moment often does not allow us to fit appropriate models to our data. Right? Did you ever encounter this warning message when working with R using the learnB4 package running mixed effects mode? Everyone who has ever encountered this warning message, please press 1 in chat. I want to see your ones. Geez, the chat goes wild, right? That's why you're here, I guess. These convergence warnings are a problem. If your model does not converge, the estimates cannot be interpreted with confidence. So what do? We reduce the model complexity. That's what we're practically told to do. That is, instead of taking into account that different speakers might show different effects of formality on pitch, including so-called random slopes, we take it out of our model. The big problem with that is that this reduction of the model that increases the chance of a false positive dramatically. That is falsely claiming there is an effect when there actually isn't. So that's not good at all, right? But we are forced to do it in that framework with that particular technical implementation. Well, that's actually an issue, again, of technical implementation only. Let's assume we do use it appropriately. Let's say we actually use it as a hammer for the nail, that is, okay? Another big issue of NHST is that it's not intuitive at all. It's quite frankly really confusing, and I hope I was able to demonstrate that just now by giving you like a super short rundown of the logic. I'm teaching stats for 10 years now, and I'm still confused by times. In a recent assessment of textbooks, it turns out that 89% of textbooks on statistical significance get it wrong. Okay, so it's not just us, even the experts find it terribly confusing. And finally, NHST does not give us the answer to our question. It's like using a hammer to nail a screw into the wall, right? We're not interested in the probability of the data given a hypothetical null hypothesis. No, we're not. We are interested in the probability of hypotheses given the data. Now, how probable is that there is a 20 hertz difference between speakers of the two groups, right? Given what I have observed in the data, that is the question we ask. That is the answer we're seeking, right? And NHST, null hypothesis significance testing, simply does not allow us to answer that question. So we need a new tool. And Bayesian inference provides these tools. It allows for robust inference. You can run the model that is most appropriate for your research question and your data set. It's logic, it's much more intuitive and in line with the way that we perceive probabilities as human beings. And it's incredibly versatile, allowing us to model all kinds of data. I will get to that later on. Now, we will introduce in this workshop one R package here that can be conceived of as the Swiss Army knife of Bayesian statistics. BRMS, developed by the wonderful Paul Berkner. By developing this package, he's done a huge service to all sciences because he made Bayesian inference accessible to a large crowd. And it made it also much easier to use Bayesian statistics for those that are already initiated. Huge service, can't be overestimated what he did here with this package. Okay, so that is what we offer. The Swiss Army knife for your research questions. Now, before we move on and I talk you through expectations for this class, we do a quick poll that Steph has prepared for us. So how should we do that, Steph? Do you just post that into the, right? So if you look into the chat, there's a link to a Google form. and we ask you to fill in really quickly this form. And there's one important component to it. You need to choose a 6-digit number that you put in there. For example, your birth date. Maybe that's not great because some people might have the same. And note it down for later because we will do that again at a later stage. Anything I forget, Steph?
That's all.
Okay, take 2 or 3 minutes and fill in the form.
Just a quick announcement, if some of you still have errors when installing the learnBAS package, you can try and install it again now. I pushed a few changes. It should work.
On Nicole just realized 0 is apparently not allowed in the 6-digit number choice. That makes it difficult for a lot of you to use dates, for example. That's odd. So for some of you it works, for others it doesn't. A little strange. Ah, okay.
Yeah, so you need to put a number from 11111 to 9999.
Oh, right.
Yes,
that's still odd. Yeah. Just note it down somewhere on a post-it maybe, so that you have access to it tomorrow at the end of the workshop, whenever that is for you in your time zone. Steph, are you monitoring the amount of results that are in already?
Yes.
You give me a go when we are at 150 or something.
Sure, yeah, we are already past that.
Okay, perfect.
161, yeah.
Okay, then I will slowly continue while the rest of you finish the poll. A little bit of expectation management, really important, okay? We are offering here a crash course into Bayesian inference, and we really hope this workshop is a springboard for you to move on, to read on, to apply these tools to your own research maybe, but to be in principle operational. What we will cover includes the conceptual foundation of Bayesian inference, how to run generalized linear models, including linear mixed effects models within this framework. And here's a biggie: how to specify priors and interpret results, and what priors are, we will obviously cover, and how to draw inferential probabilistic inference from the results. Right? That's what was advertised. You know that already. What's more important is what we won't cover. We will not be able to cover an introduction to R, to the functionality of R, or more advanced data carpentry tricks. That is the ability to alter and shape R objects, like, for example, data frames. And this is important because BRMS won't give you immediately what you might need if you want to make traditional plots. It requires a minimum amount of wrangling, a skill that we don't have the time to teach here. In our materials, there are examples that you can try to use, and you can try to inform yourself about the packages that offer these functionalities. It's a good springboard, but we can't cover this. And more importantly, we cannot introduce you to generalized linear models. This is not an introduction to statistics, unfortunately. We don't have the time for that. So we will assume that you have some experience with R, and that you understand what a linear model does, how to interpret regression coefficients, etc. Right? We posted into the Slack channel and our emails. I think we suggested resources to brush up your skills. I highly recommend Bodo Winter's book on Introduction to Statistics for Linguists, I think it's called. Bodo Winter, most of you know him. Fantastic book, very, very accessible, I think. So yeah, if you need some brushing up, that's a good resource. Now, how do you get the most out of it? I suggest you use the Slack channel, right? There, I think we have 150 people plus now in the Slack channel. This is a great place to form a community, to exchange questions and answers with each other, resources with each other. We hope this is a good environment for you guys. Well, have your machine prepared in BRMS in the sense that it should be prepared now, because we will jump into it right away, right? And that is not trivial. That's why we sent out the emails weeks ago. BRMS is, utilizing some mechanics that are a little bit more involved than the usual R libraries that you all know. So please make sure that this is running. If not, follow along as much as you can, and try in after the first day, try to get your machine ready. And most importantly, relax. Okay, try to relax. All materials and the recordings will be available immediately. The slides are available already. The R markdowns are available already. The recording we will share as soon as we can. And we also plan to make short pre-recorded content videos of the parts that we are presenting. So this will all be available to you later on. You can revisit. So relax, take in whatever you can take in, and don't panic. Very important point. This is a learning opportunity, and it's a success. Its success depends mainly on how well the instructors, that's us, communicate the content. If you don't understand something, that is not on you usually. It's on us. Right? We will try to pick you up where you are, but sometimes our attempts are not good enough. Right? Also keep that in mind. Usually it's our fault, and we can easily blame us. And if you want to blame someone specifically, go for me. Also, be kind to yourself. This has been a rough 1.5 years for all of us, and we might not be as good as we want to be at absorbing information. Right? So if something doesn't stick, know that you can revisit our materials later on outside of the class, and you can always ask questions in the chat on the Slack channel. Now, speaking of being kind to yourself, please be kind to fellow participants as well. We have a very colorful mixed bag of people in this crowd, a lot of students, but a lot of early career researchers, faculty, non-faculty, and a lot of senior researchers as well in tenured faculty positions, right? So please keep that in mind. We would like everyone to feel comfortable here to ask questions without feeling judged by others. If you don't feel comfortable asking your question, with your name, then use the anonymous function in the Google Slide. This is not a competition, but a really cool gathering of a large proportion of our field, it seems, and that's really exciting. So let's do this. Okay, let's try to learn together. And here is our roadmap-ish. Okay, I just walk you through it real quick. Day 1 and day 2 is today and tomorrow, and we aim for 4 hours. We will, after this now, jump immediately into running our first Bayesian model with Joseph. Okay, immediately. So we will have the first success in the first hour of the workshop. I will then take a step back and talk you through the Bayes theorem, a little bit of a foundational conceptual topic. We try to understand what it really means to be Bayesian. And then we will have a large chunk that Stefano will present, in which we talk about priors. What are they? How do we specify them, etc. And I will end the day today with a comparison between null hypothesis significance testing and Bayes, to kind of remind ourselves why we're actually here and why we should come to the next day. Day 2 will be a short review. And I will probably take into account your questions that come up today, so I can kind of cover that in the morning, at the beginning of the session, wherever you are. Then we talk about how to do inference, right? How to, don't want to say test hypothesis, but how to answer your research question using the posterior and Bayesian analyses. And then more on priors from Steph again, and in which we talk about why it's really important to use priors. And then I will live code with you your first mixed model in Bayesian land, right? Hopefully you will have all the tools then to run a simple linear mixed effects model using the BMRS package, okay? And at the end of the day, tomorrow, we will talk a little bit, Joseph will talk you through a little bit what's under the hood, because that's not that trivial, and there are some practical implications for how the machine under the hood works, right? We talk about sampling. Now, the third day is a little bit of a wild card. So you have 6 days between the second day and the third day. And on the third day, we have not planned content. We planned originally, and we'll see how well that goes, that we offer a one-on-one service to you guys, short sessions where we meet with many people if they want to, and possibly talk about a particular hurdle they experience applying Bayesian analysis to their data set, right? For that to work, we really need a very good structure. We will prepare a sign-up sheet, and we will ask you to specify your question as succinctly and as clearly as possible in advance until Friday evening. I think that's what we decided, so that we can prepare for your question and that we can use the time efficiently so that we can actually talk to as many people as possible. If the demand is much higher than what we can supply, we'll have to figure out alternatives, but we will inform you about that, I guess, at the weekend. So that is it so far. Let me stop share. And remind me, Steph, Joe, what's happening now? Do we have a break immediately, or is Joe starting immediately?
Joe is starting, yeah.
Okay, perfect. I will switch off my cam.